Hey guys, welcome to your Chapter 8, Lesson 8 notes on factoring by grouping. By the end of the day, you will be able to factor higher degree polynomials by grouping. And by higher degree, I mean something bigger than x squared, maybe even x cubed. So let's just do 5 examples now. Here's the key. I'm going to tell you the key right away. Key idea. When factoring a polynomial with more than 3 terms, look for the GCF. You're going to put them in groups and then look for the GCF. So our first group is this guy right here. Let's find the GCF of those. So the GCF of these 2 terms is going to be 6x squared. That's a 6x squared times x plus a 6x squared times 2. Super duper, right? Okay, cool. Now let's look at these 2 terms. What is the GCF of these 2 guys? 4. That's a 4 times x plus a 4 times 2. Now look at this. We've got an x plus 2 and an x plus 2. That is no coincidence. Amazing. We're going to undistribute. Oh, it's equals. Now we can undistribute this guy. Awesome. So we're going to pull an x plus 4 out, and we're left with 6x squared plus 4. Because we had 6x squared times x plus 2 plus 4 times x. Just kidding, it's not x plus 4, it's x plus 2. Haha, gotcha. Okay, anyway. We got a 6x squared times x plus 2 plus 4 times x plus 2. Woo, so good, right? We're not done though, because check it out. 6x squared and 4, what did they have in common? They have a GCF in common as well. So did I just not do that right? Yeah, I could have factored it out at the very, very beginning, couldn't I? Anyway, 6x squared and 4, they're both divisible by 2. So we can pull a 2 out, giving us 3x squared plus 2, and then x plus 2. And then that's the final form. So at the very beginning, if I had noticed, hey, look, these guys all have a GCF of 2. I could have factored them out at the very beginning, but I didn't notice that, so I did it at the end. And that's fine. Yay, right? Cool. So what I'm going to do, guys, is I'm just going to talk you through 4 more examples, and then we're going to sum up this entire chapter in one key concept box. So here we go. All right, so what we're going to do is we're going to split this into groups. We're going to look at these guys as one group, and then these guys as another group, and see what we can factor out. So I don't make the same mistake I made last time. Do they all have a GCF? No, they don't. So re-put those boxes on there. Awesome. So the GCF of our first section is a 3n squared. Factoring a 3n squared out of each of those gives me an n minus 4. Sweetums. Now in our second bluey guy, we can factor out a 2. Cool. Leaving behind an n minus 4. Oh, hey, check it out. They have an n minus 4 in common. So we're going to pull him out back. N minus 4. You can also, fun fact, if you want to pull him out forward, that's fine. It looks easier to me to have the 3n squared plus 2 out in front because that's the order that I originally wrote them in. If you would rather rearrange them, you are allowed to do so by the multiplication property of, the commutative property of multiplication. You can rearrange them if you want. That's fine. Whatever. I actually don't like to do that. I like to have the n squared out in front. I like to list my factors by degree. So we do n squared first and then n squared. But anyway, there is it. You are done. Next. Do these guys have a GCF? No, they do not. So we'll split them into little groups. We've got our magenta group, and we've got our sky blue group. Here in magenta, we can factor out a 2t squared. And we are left behind with a 4t plus 7. And then our bluey guy, we can factor out 5. That's exciting. So we're left with a 4t plus 7. Oh, hey, what a coincidence. Whoa! Come back to me. These are the same. If they're ever different, that means you did something wrong. They will be the same. So 4t plus 7 and 2t squared plus 5. Factor is done. Oops. Yay. Alrighty, we'll do one more example. And remember, just keep going. That's the trick. Just keep going. Do what you can. So I look at this and I notice, 4. They all have a 4 in common. So I'm going to factor out, oh, not only a 4. Guys, check it. They all have 4q. So I'm going to start with that GCF of 4q, leaving us with q. Cubed minus 2q squared plus 3q minus 6. Awesome. Now that 4q is going to stay outside real quick, and then we're going to figure out, okay, what's our GCF of this guy and our GCF of that guy? Well, that's a parenthesis. Nice big old parenthesis right there. They don't match, but that's okay. They're like eyebrows. They're supposed to be sisters, not twins. Right? Okay, anyway. So we got a q squared times q minus 2. Plus, and then out of here we've got a 3, giving us a q minus 2. Okay, cool. So we can factor out a q minus 2 out of there, leaving us with a q squared plus 3 times q minus 2. Now it's up to you what order you want to put them in. I think that's fine, so we will leave it just like that. Cool beans, cool beans. And then finally here, start by factoring out the GCF. So I see they all have a 3 in common. And they all have an h in common. That's so nice. Okay, so to get rid of a 3h from each of these factors, we are left with 2h cubed plus 3h squared plus 4h, where's the club, plus 6. Sweet. Now, let's continue to factor by grouping. Out of our magenta group, our GCF here is a h squared, and that leaves behind a 2h plus 3. And then out of our blue group, we take out a 2, and that leaves behind a 2h plus 3. We know we did it right because they match. The 2h plus 3's are the same. So it gives us a final factored form of 3h times h squared plus 2 plus 2h plus 3. Fun trick, how do you know that you factored it correctly? Well, did the number of variables match up with the degree that you started with? Then you probably did something right. So here, how many h's do we have? 1, 2, 3, 4. Oh, look, 4 of them. Awesome. How many q's do we have? 1, 2, 3, 4. All right. Here, how many t's do we have? 1, 2, 3. All right. Here, how many n's do we have? 2, 3. Sweet. Oh, how many x's do we have? 1, 2, 3. Awesome. So there you go. Count up the degree of the variable. That should match the degree of your starting polynomial. Okay, so what have we been doing this whole time? Well, first, we factor out a GCF. And then we check how many terms a polynomial has. If it has 2 or 3 terms, then look for a difference of squares, perfect square trinomial, a pair of binomial factors. So remember, difference of squared is when you have like a squared minus b squared type of deal. A perfect square trinomial is where it will factor to a plus b squared. So that'll be a squared plus 2ab plus b squared. Or if you have a pair of binomial factors, that's where you have like a plus b times c plus d, and you would have FOILed it out to get something like that. Except I totally FOILed that wrong, but you get the idea. However, if it has more than 2 or 3 factors, if it's got like 4 or more, group terms. So you do the group thing like this, and then you factor out to find common binomial factors. And then for a final check, make sure there are no other common factors in these factors other than 1. So in your parentheses themselves, you need to make sure that they don't have a GCF. This went wrong earlier in our very first example when we said, oh, shooties McGooties, look at these guys. They've got a GCF. You need to keep factoring until each of these guys doesn't have any factors in common. Whoops. Yep, that's it. So I hope you have a wonderful time on your homework.